Good morning, everyone, and welcome to our webinar today. So we have a webinar on meeting the RECOUP Awards 2023 finalists for our product-related categories. I'm just going to give a quick introduction to RECOUP for anybody who isn't aware who we are. So RECOUP is the UK's leading independent authority and trusted voice on plastics resource efficiency and recycling. As a registered charity, our work is supported by our members, and we have over 170 members as part of RECOUP who share our commitments, including a more sustainable use of plastics, meeting legislative requirements, increased plastics recycling, and improved environmental performance. One of our real strengths is connecting the whole value chain to keep plastics in a circular system that protects the environment, underpinned by evidence and knowledge. And we do this by leading, advising, challenging, and educating. So our work spans a number of different areas, and you'll soon see these are very much related to the awards categories that we have this year. So anything from looking at reuse and refill to packaging, recyclability and design, plastics in the environment. So a whole host of different areas. And if you'd like to find out more about these, then please do just get in touch. So on to today's topics, the 2024 RECOUP Awards. So they're now open for entry. As you can see, we have 3 different awards categories. So Best Plastic Product Development for Recyclability or Reuse, Best Innovation in Equipment or Technology, and Recycled Plastic Product of the Year. Today, we're going to focus in on the 2 product-related categories, so the Best Plastic Product Development and the Recycled Plastic Product of the Year, and hear from some of our shortlisted entries and winners from last year. I'm also going to talk you through the application process. So it is free to enter. The awards themselves are presented at a networking dinner on the 25th of September 2024, which is actually the night before the RECOUP conference. So the RECOUP conference is held on the 26th of September. It's a great event, attracts normally over 400 delegates. The networking dinner the night before, we have incorporated the awards. So again, a great opportunity to network with the supply chain and show some of your innovations. So the 2023 awards, who will be hearing from some of the winners and shortlisted products today. So the ones highlighted are who we're going to be able to hear from today. So in terms of the best development or innovation to enhance plastics products for recyclability or reuse, we'll be hearing from Magnoma, Nextech and Zotefoams. Recycled Plastic Product of the Year, we'll be hearing from the winner, Sequel Initiative, who have sent in a recording to share with you. So the entry criteria, there are entry criteria for both awards, not too strict on what we ask, but we are just asking, as everything we do is based on evidence and knowledge, we're asking you guys for evidence and knowledge around your product developments. So in terms of the best plastic product development for recyclability or reuse, we are asking you to demonstrate, and particularly for recyclability, that it is collected, it's sorted, it's reprocessed and has an end market in terms of its recyclability. Obviously, we see a lot of claims about recyclability, which can relate to the collection phase, but we are looking for every phase to be met. And for reuse, for it to be part of a reuse system in the same way and have that evidence that it is implemented for reuse. For the recycled plastic products of the year, obviously the criteria for that relate to the recycled content, being able to or share with us whether it's post-consumer or post-industrial recycled content. As it says there, we do not, the criteria are not met if it's from post-production scrap, so it does need to be post-consumer or post-industrial. There is no minimum restriction percentage of recycled content, but it must be disclosed what sector the recycled content is coming from, the country, and the country from which it is sourced. And then I've put 2 criteria there which fit across both of the categories. So it must be innovative, and we do ask that in the questions to share with us how it's innovative, in whether that's its aesthetics, design, or the impact. and must be sustainable, fit for purpose, market needs and marketing potential will be considered. I forgot to mention, if anybody does have any questions, then please pop them into the Q&A and we will answer those. In terms of entering, it's super easy. So the entry form is on the RECOUP website. So you can see there www.recoup.org/RECOUP Awards 2024. It is free to enter, as I mentioned. So the links on the website will take you through to a SurveyMonkey where you'll have the opportunity to answer the questions. They are not restricted by a word count. It does have the small boxes on SurveyMonkey. So if you find that you're struggling to get the content into those, there is an option to upload additional content as well. So you can add attachments in which you share further information with us. So these are the questions that you will need to respond to for each of the categories. So again, we have 2 distinct questions for each of the awards, and then we have a number of questions that are the same for both of the awards. So in terms of the best plastic product development for recyclability or reuse, it's talking about the need for the product to be improved regarding its recyclability or reuse, and what impact the new design has made in terms of that recyclability or reuse. For recycled plastic products of the year, again, it's why did you choose that product? Why that market sector to use recycled plastic content? And how much recycled plastic content does your product contain and where this was sourced from? So going back to the criteria, we really need to understand what recycled content is being utilized, where's it from, and that transparency in the application is appreciated. Then for both categories, it's outlining the development phase for whether it's improvements or the new product, including any date, if it's launched, if it has been launched to market. What's special about the product and its design? So what sets it apart from competitive products? And then you've got room to include information on its innovation, the design, ergonomics, aesthetics, market reception. So you've got a real opportunity to include some unique details about your products in the application. So that's the entry form, hopefully not too onerous, but really we want it to get a real flavour for your product. It's your opportunity to share all the information that makes your product unique, sustainable. So important dates. The entry deadline is the 28th of June. So you have until the 28th of June to submit your entries. You are not limited to number of entries. Obviously, it would need to be different products, but any company can apply with a number of different entries. And again, free to enter. We will need a sample of the product. So these are required to be sent to the RECOUP offices by the 5th of July. This will then allow us for the judging will take place in July. So we will share the information with our judges, made up of 2 RECOUP board representatives and 1 external representative. Week commencing the 5th of August, we plan to share with you our shortlists, and we'll obviously share a press release around who we have shortlisted as well for our awards. Then, as I mentioned, 25th of September is the award ceremony. So that is combined with our pre-conference networking dinner. Any shortlisted companies will receive 1 free in-person ticket to this event, to the networking dinner. And then the 26th of September will be the RECOUP conference, and shortlisted companies will also receive 1 free in-person ticket to our conference. And that's just a reminder that tickets are on sale for the RECOUP conference, so you could get in there early and book your tickets now. They are free for RECOUP members anyway, so please do make sure that you get signed up for the event. So I'm going to stop sharing my screen now, and we will move on to some of our shortlisted entries for the best development or innovation to enhance the recyclability or reuse of plastic products. So first, I would like to welcome Vishal Salian from Magnema to talk about their entry for last year.
Hi, everyone. Uh, Hi, my name is Vishal Salia. I'm the head of innovation for Magnomer. Magnomer is a design solution to help recycling of shrink sleeve bottles in PET recycling. Currently, the problem with recycling is that the bottles that are produced are not designed for recycling. The poor package design, for example, shrink sleeve labels in PET bottles don't allow for easy sortation of the materials during the cycling. What this means is the labels that are useful during the use become a contaminant during the recycling process. What this results in, Magnoma resolves this issue using a transparent magnetizable coat. We have a suite of solutions for shrink sleeve labels, pressure sensitive labels, and multi-layer packaging. What we're able to do is provide a drop-in solution, which is a transparent coating which can be applied during the label printing process. And it allows for the separation of the problematic labels during recycling with the use of existing magnets. This is especially relevant in terms of the requirements of recycled content, recycled plastic content in single-use packaging, which is currently not being met by the existing infrastructure. Our coatings, as I mentioned, are a drop-in design. They can be printed using existing high-speed printing processes, including gravure and flexographic printing. They are food safe. They are food safe. They contain no heavy metals or toxic components. And they abide by US and EU FDA guidelines, so food safety guidelines. And lastly, the magnetizable properties of the film allow for them to be sorted out during the recycling process, making a non-recyclable packaging into a recyclable packaging. Technology is based on the US patent that was issued earlier this year. Now, I'm going to walk you through how this would actually work in the recycling infrastructure. Typically, at a recycling plant, bottles are received in a bale. They are then ground into 3/4 inch cornflake style flakes. The flakes have a variety of contaminants, including labels, bottle caps, as well as metals and aluminum cans. They're sorted through a variety of processes like sink float, where materials that are lighter than water, like polyolefin, polypropylene, and polyethylene caps and labels, float off, whereas PET sinks. Shrink sleeves made of PETG and PVC sink with the PET flake, becoming contaminants. What Magnomer does is it uses magnetic separators that are present downstream from here, and it sorts out the label uh, without hindering any of the operations upstream of the magnet. This results in clear PET flake that can then be recycled back to bottle grade. I'm going to show you a couple of videos here which will demonstrate our technology. The first is a print. It's a commercial print. In this video, this is a solvent gravure printing press where our coating is printed on station number 6. It requires one single station. The coat prints as a transparent varnish before the colors, after which the colors are printed, and it does not affect the graphic in any way. Next, I'm going to show you a separation video. This was taken at a recycling facility in the US called Evergreen Recycling, where we fed in a 1 ton of bottles with Magnuma coated labels, and we ran it at 4 tons per hour for 3 hours. We starting with a 50% label concentration, which means about 4,000 ppm of label, we were able to get less than 20 ppm label as a final out. What you're seeing here is a magnetic pulley separator. The PET flake is flowing from left to right, and the pulley here is pulling the label, which is magnetic to the left of the splitter. As you can see, almost all of the label is separated to the left, while the clear PET flake flows to the right. Based on this data, in addition to 2 other commercial scale recycling tests, where we were able to demonstrate greater than 99% removal of contaminating shrink sleeve labels, we were able to show less than 20 ppm, which is less than the desired target allowable concentration of labels in the final product. Based on this information, we received the APR's innovation recognition in June of this year. Just looking at a comparison of the existing technologies that are there to address the issues, we see that all of the existing technologies, there is either a issue with compatibility with the packaging design, or requiring a new capex. Magnuma is a drop-in design that works with existing infrastructure both on the recycling side as well as on the manufacturing end, with minimal cost tags. We believe our technology can work with the brands to provide to make the packaging, design the packaging in a way that it can be recycled effectively at a recycler. We've now demonstrated our technology in the US and in India, and we've launched in the US and Indian markets. As I said, based on the commercial scale test we did, where we ran 250,000 bottles at multiple reclaimers, we received public recognition from the recyclers and the certification from the APR. We've subsequently also received recognition from How to Recycle. The Magnuma team consists of Ravish, Vishal, and myself. So Ravish, Kumar, and myself. We are a US and India based company. Working to help resolve this issue. So, as I said, ours is a solution that is a drop-in into existing existing manufacturing processes, but it allows for a shrink sleeve bottle to become recyclable despite no changes to their manufacturing process. That's it for me. Happy to answer any questions.
Thank you very much, Vishal, for sharing that with us. If anybody does have a questions, then please just pop them into the Q&A. I was just wondering, how did you find the entry process last year to the RECOUP Awards? And was it a specific application of the label that you entered for a product, or was it in general
we had applied for the shrink sleeve labels?
Yeah. Okay, so shrink sleeve labels. And how what's the market penetration of your labels at the moment? How optimized are they? How utilized?
We are actually just getting started. We just launched in the in both US and India market in Q1 of this year.
Excellent. Great. Very exciting developments, and thank you for sharing that with us, Vishal. So next I'd like to move on to another of our shortlisted entries for the best development or innovation to enhance plastic products for recyclability or reuse. We do need to shorten to some snappier awards titles, but to introduce you to Neil Court Johnston from Zope Foams.
Thank you very much, Catherine. And just to say at the outset, we would recommend to people watching this webinar to get involved with the RECOUP awards. We found the process to be very straightforward and really an excellent networking opportunity. We've made some very valuable contacts through the awards process. So do get involved. The technology that we're speaking about is Resource, which is a monomaterial food contact barrier packaging with up to 70% recycled content. And maybe just a quick piece of context, if we look at the Ellen MacArthur Global Commitment Progress Report, the latest one issued in November of last year, what it demonstrates is that the very best brands on the planet, by design, are doing a fantastic job in terms of recycling recycled packaging. The area that's highlighted on the screen demonstrates the metric which they're all really struggling with. They've made public pledges in terms of the percentage of recycled content in their packaging, and they're all really struggling. And you know, if we look at, for example, Nestle, the world's largest food business, you know, they are struggling really to get anywhere close to the 30% recycled content commitment in their packaging. So it's a big issue for industry. And we also know, if we look at the retailers' packaging policies, that complex composites are really on their way out, and it's about monomaterial circular packaging materials. And on the screen, those that are listed in the green category here with Tesco's policy are some good examples. Last slide by way of context is that when we've looked at the packaging category as a whole with the technology, we've identified that composite beverage cartons are a major problem for the world. 6 million tons of these cartons go into landfill or are incinerated around the world every year. The total consumption is about 300 billion cartons. So it's a massive problem, and that really tees up Resource, as I say, a fully recyclable monomaterial food contact barrier packaging. And if we look at the technology, we are creating a microcellular structure with up to 70% post-consumer recyclate. Within the gauge of a crisp bag, we create sort of 9 layers, and by using atmospheric gases, nitrogen and carbon dioxide, we're able to create a film or a sheet which is as flexible and floppy as a piece of paper or as rigid and stiff as a piece of card. We create outstanding barrier properties, and we're able to create a dead fold actually in plastic, which means that we can create any shape. I'll talk a little bit more about life cycle assessment in a few moments, but critically, you know, when you're talking about bringing new technologies to the market, very often they can be complex, they can be quite costly. The Resource technology that we're talking about here is fully compatible with the existing extrusion processes, the existing packing and filling processes with just some minor changes, and is recycled through the mechanical waste stream, much in the same way as an HDPE milk bottle is today, in terms of disposing of that and it being circular. The resource sheet, as I say, is extruded using existing extrusion processes. We make some very minor modifications whereby we are introducing proprietary technology to inject the atmospheric gases into the polymer. Typically, we're displacing about 10 to 15% of the polymer, as well as making it stronger and lighter. That creates a roll of material, and if we take beverage cartons as an example, because this will be our first product launch, we then run that sheet through an existing filling line, whether that's a Tetra Pak line, an SIG, or an Elopak line. Some very minor modifications that we need to make, because today those liquid paperboard products are heat sealed, and with us being a 100% polymer product, we're using ultrasonic sealing. And then the product, once consumed, is disposed of using the consumer will put it in a recycling bin, and it will be collected as a mono-material, high-density polyethylene container and closure, tethered closure, that will be recycled. Typically, when extruding plastic, it can create this sort of orange peel effect on the surface when you try to print onto the plastic. We've done a lot of work with all of the various print technologies. So, for example, we've been working with digital printing, with flexo, lithogravure, and we're actually launching our first beverage cartons very shortly with a major European retailer in the form of a reverse laminate BOPE print solution. Really an excellent print surface. Talking about life cycle assessment, so we've sort of, through this process, we've had support from a number of British and European universities, and when we have benchmarked the resource 1 litre monomaterial HDPE carton versus what might be considered the market standard aseptic beverage carton on the market today, and we've assessed the impact on the environment across 26 different impact categories, what we see is a 50% or better improvement in every single category versus the current market standard. And notably, sort of, the three that trip off the tongue would be carbon footprint reduction, energy and water, significant reduction and improvement. Last couple of slides. We're conscious that there's a lot of claims that are being made in the market that are not always evidenced by the OEMs, and so our packaging, the beverage cartons that we'll be launching, we will have a QR code on the package. We're partnering with a company called R-Cycle, and that's effectively giving us a digital product passport, so you'll be able to trace the material that we're using, and to evidence that it's a promise delivered when we talk about circular packaging. We had a success with RECOUP, and also with the Plastics Industry Awards, where Resource was recognised as the best recycled plastic product of the year for 2023. And I think in terms of what you will see in the marketplace, we have a joint development agreement in place with a major packer and filler. We will be launching these cartons in 2024 with a European retailer, and we're very interested to now take the technology to new applications. So different sizes of carton, but also now moving into flexibles, pouches and sachets. And one of the the key differentiators, because there are a number of mono-material pouches on the market, but the USP here being that 70% recycled content that we're able to capture in the substrate. You'll see, as in the BIFA annual report, you'll see us in the International Fruit Juice annual report. And thank you for your attention, and look forward to continued collaboration with RECOUP.
Thank you very much, Neil. Really interesting insights there into the carton for Zote foams. I did have a couple of questions. Well, actually, first thing, just something I noticed, very applicable product that could be entered into the Recycled Content Award as well. Just a note there for potential for an entry this year. In terms of the recyclability criteria talked around, it has to be shown to be collected, sorted, reprocessed, and have an end market. Are you able to talk a bit more about how you tested that in the development of the project, or the product?
Yes.
Sorry.
Yes, certainly. I mean, one of the partners that we've had on the project pretty much from day one have been BIFA, and they have been very supportive. They have laboratories in the northeast of England, and we have been testing and retesting in terms of melt point, in terms of color, odor. There are many different tests that they've applied. That's then led to in Europe working with IKTR and RECOUP, and we have a lot of data available if anybody would be interested to see that.
Great. And we've just had a question come in. Have you got any comment on the separation at MRFs? So I'm guessing where does the material go? Does it go into the milk bottle streams? Does it go into a HDP general stream?
Yes, as a mono material. So I think maybe one of the things that's helpful to understand is that 95% of this product is polyethylene, and so this is sorted as a PE at the MRF, and as I mentioned, we also have a PE tethered closure as well. So and that 5% that isn't PE is your atmospheric gases, your nitrogen and your carbon dioxide, and we typically use a very small element of barrier agent just to sort of supercharge the barrier for food safety.
Great, thank you. And then off the back of that question, just another one that's come in. Do you envisage a closed loop for this product?
That's a great question, and yes, this is applicable for closed loop recycling. This is again, BIFA are the largest UK reprocessor recycler of monomaterial HDPE milk bottles, and they've confirmed through their tests that this would be something that they would be happy to have within the UK closed loop recycling system.
Great. Sounds like lots of exciting developments to come. I just had one other question. So you talked around other applications for this technology for other packaging items, so pouches, cartons, sachets, etc. But are there any non-packaging plastic applications that you're working on?
That's a very good question. The honest answer is that there are many non-packaging applications that this will be applicable to, but this is keeping us busy enough at this stage. So maybe that's a one to come back to in the future.
Definitely. Okay, thank you very much, Neil, for sharing that with us. So going to move on to our next speaker, Ed Cozier from Nextech, who's going to share his entry for the best development or innovation to enhance plastics products recyclability or reuse. Thanks, Ed.
Thank you, and thanks for inviting me to have this discussion today, Catherine. So our project is, I'll just come back to that last slide. Our project is called CO2 Clean, which is related to the decontamination of post-consumer polyolefin films with the target of making them back to food grade materials. Just to say a few words about Nextech, we're a technical development consultancy. We get involved in developing recycling solutions for post-consumer plastics, and typically our targets are to take these materials back to food grade. We also design recycling plants, and we work with brand owners to help them reach those targets that Neil was talking about, to reach their recycled content targets that they've been working on. One of the reasons why we've focused on working on plastic films is that globally, plastic films are the least recycled materials. And of course, they are also very widely used. The global market for flexible films is estimated to be 32 million tons per annum. So it's a significant component of packaging materials. And food grade films are roughly a quarter of that total market, with something just over 7 million tons per annum used in food packaging. And at the moment, most polyolefin films are either disposed of to landfill, or they go to waste to energy. And if they are being recycled, they're going to other applications where they're going into non-food areas. And we can see that the market for USA is roughly 3.5 million tons. And at a recycled content, that would represent a market opportunity of about 1.8 million tons. Now, our target focuses on low density, high density, and PP films. And the idea is to take these back to food grade. In our sort of projections about what could this, could this be a viable solution? We'd only need 5 plants. In 5 years, we'd need 10 operating plants, each processing 6 kilotons per annum to produce 60,000 tons, providing 30% recycled content for food packaging. And in the there's a scale-up result for this in USA. And in achieving these targets in both Europe and USA, we would save something like 2.4 million tons. So the opportunities of recycling films would be significant if we can actually get to these sorts of final targets. And this is really where we targeted CO2 Clean. We have a project which is Innovate UK funded, and we have 8 organisations involved. We've got 4 innovation partners, University of Nottingham, Bangor University, Bioextractions Wales, and Nextech. We're working on the development of the technology. And we also have companies like Unilever, Amcor, who are both brand owner and producer of films, and Allied Bakeries as a big user of packaging materials for bread, and Viridor as a recycler. So the process of working with that we're working with, called CO2 Clean, is a decontamination process, and we use carbon dioxide in the supercritical phase, and we're using this as an extraction solvent. Now, this is similar to other processes that use supercritical carbon dioxide as a solvent, but in this case, we have a non-toxic material. And we know that we can remove greater than 99% of any oils and chemicals that may be in contact with film materials, with polyolefinic film materials. And we've conducted a series of challenge tests that comply with US FDA and EFSA to estimate these levels. And this performance is quite uniform across all of those polyolefin materials. And that's rather unique for a decontamination process. We know that using a supercritical CO2 extraction process is energy efficient, and it saves something of the order of 65% CO2 emissions compared to virgin PE. So roughly a saving of 1.3 tonne per tonne of virgin PE that would be replaced by this. The decontamination process actually extracts all volatiles and semi-volatile materials, which means that the recycled films have no odor and no smell, which is often a feature of other recycling processes. We also can see that the technology can remove inks when we use green co-solvents with the CO2, and those solvents can be recovered. These are non-toxic solvents, things like alcohols that are widely used and other similar materials. And this way we can actually remove inks, which actually improve color and quality and also reduce toxicity issues. The process can also delaminate and demetallize multi-layer films. And this is another big opportunity for a process like this, where it can potentially unravel the more complex materials that have been used in the system. So this process doesn't use water, which is often a big feature of conventional recycling. So that means we have lower costs of operation. We also have no need for drying, which removes a big energy component in film recycling. And of course, CO2 is non-toxic, and all the materials that we're using are actually recycled within the process. And we have no diluted residues or wastes coming out the end, because we get the concentrated contaminants coming out of the process. For those of you who want to know a little bit more about decontamination rates, here's our table based on the EFSA challenge test. And in this case, what we do is we have a list of what we call surrogate contaminants. These are chemicals that we apply to the polymer in a solvent-based system. So we pre-contaminate film, and then we actually put the contaminated material into our process and then look at the decontamination rates. So we can see that for example, on the left-hand side, you'll see toluene, chlorobenzene, limonene, phenylcyclohexane, hexyl salicylate, benzophenone, and isopropyl myristate. These materials are added to the films at levels of the order of typically targeting 1,000 parts per million. In some cases, we've gone higher. But when we apply the recycling process, we can remove typically 99% or going up to 100% of these materials. In other words, beyond the limit of detection. And that's uniform for PP, HD, and low density. And this is another trace which shows the capacity to remove oil and greases. This is a sample of PP film material. And these two traces are GCMS headspace traces, showing that on the blue trace underneath, the peaks are representing molecules that are present in the polymer, and you can see the trace, the orange one afterwards, shows you a much flatter trace, especially in the longer residence times, showing we can remove oils and greases, which is something which is quite unique. Many decontamination processes struggle to remove high molecular weights, whereas this process actually is very efficient with those materials. And at the bottom, you can see other hydrocarbons, which are typically in polymers are also removed at high removal rates. And the residual peaks you see there are characteristic of polypropylene, so coming out of the polymer itself, which are conventionally always there. So just to say a few words about metallized materials, we found in our process we can actually penetrate the layers and create delamination between the layers. So this is a crisp packet, which you can see what the film looks like beforehand and also what it looks like after the process. So we can actually delaminate the layers. In this case, we end up with 2 PP layers on the outside and a linear low density layer on the inside. And this is quite a simple and also quite a powerful process for demetallizing. And in this slide, you can see the SEM's images of the demetallized, of the delaminated materials. So a very interesting and very important technology to have. We know that multi-layer materials are being replaced by mono materials, but we still have quite a lot of metallized and multi-layer materials put on the market. So potentially this process could be used to deal with some of that complexity. On the de-inking side, here we're using printed films. The first 2 examples are from the crisp packets, and by using a co-solvent with the CO2 in the supercritical state, we can remove the inks. And also on the right-hand side, we've created oily films where we've just simply soaked the films in oil, and we can remove those oils again in the process. So these are quite important steps in the recovery of films, because many films are both printed and oily. And so we have now techniques where we can apply this process using what is a relatively widely available and safe solvent to use. This project was recognized by the Alliance to End Plastic Waste as the winner in their circular solutions for flexibles. That project, it means that we have the capacity to design and build the first demonstration plant. This process is underway. You can see some of the team working on the scale up of the process. That the plant's been designed, the food dossiers are in the final stages of completion, and the project is working its way through the Alliance in Plastic Waste committee process for approval of all the final stages of the plant. So a very exciting and busy time for that project team. So just quickly in summary, this technology was developed to tackle this big waste issue of what can we do with plastic films, and it's working on what we see as one of the big limitations of not being able to enter the food market again with recycled content materials. So we believe that this is a big contribution back into the circularity of the use of plastic films in the marketplace, and will act to reduce the amount of material that would otherwise be directed to lower value applications or ending up in landfill or waste to energy. This project is funded by Innovate UK, and of course, in the near future, it's being funded by the Alliance in Plastic Waste in terms of building the first plant. And as we've mentioned, we've got some unique properties in terms of using carbon dioxide as a supercritical solvent. And of course, we know that we've got savings in energy and resources. So with that, I'll close and allow some time for questions. Thank you very much.
Thank you very much, Ed. Really interesting application of technology there to improve the recyclability of films. I had some questions. You talked about the focus, the target materials. In terms of the input streams into this technology, do they need to be pre-sorted before going in?
Yes, like any recycling process, if you're going to recycle a polymer like polypropylene or high density polyethylene or low density, they need to be segregated into their own streams. Sorting of films is completely doable. You need to pre-prepare the material by shredding, and then it can be sorted using near infrared. Now, and this does require a specialized air-assisted sorting system, but both companies like Pellenc and Tomra have these machines on the market for a number of years. So yes, they do need to be pre-sorted. There's no in the recycling of polymers, there's no magic wand where you can do everything with a step. This process is a decontamination process, so pre-sorting is an important part of the starting of the process, and then we can decontaminate, and then those decontaminated materials can be processed by extrusion into pellets and then put back into food grade applications.
Great. And obviously before sorting, the primary thing we need to do is collect the material. And we know there are projects like Flex Collect, trialing these collections of flexible materials. Do you have any thoughts? Is this an aspect you've looked into for your project?
Yes, indeed. And we are in contact with Flex Collect, and we will be taking post-consumer films. And we are also working with recyclers to take those input materials. So we've validated the decontamination process, and the demonstration plant will be able to take significant volumes of these collected materials for reprocessing. And of course, recycling is all about closing the loop. So we have to have collection at the very beginning, processing technologies in the middle, and then end markets at the end. And those markets will be greatly enhanced if we can make a food grade material, because it represents a much higher value to the end user and the brand owner if we can do that. And that's the whole idea of creating a technology that creates high value end products. And hopefully this will be a big contribution to the recycling of that very difficult phase of materials of the flexible films.
Yes, indeed. Yeah, thank you for sharing, Ed, and look forward to the developments that come out of the project. Thank you. So just to finish our webinar today, we have got a recording sent in from the winner of the Best Recycled Plastic Product Award last year, which was Sequel Initiative. So I will just share that recording with you. I'll be able to hear from them. So I'll just play that now.
Good morning, my name is François from Sequel Initiative, and I hope that together we will clean the ocean. So we have a big issue in recycled world right now, the fact that 9% of the plastic is being recycled, and there is an equivalent of 1 container every minute that is dumped into the ocean. We have also the fact that 15 million people are really making their living as waste pickers, and we need to improve their standard of living. And then the fact that that many recycling companies are failing to communicate the origin, the traceability of their material. In the case of Sequel, we are a proper ESG solution, an environmental one, obviously, by implementing a circular model to removing plastic from the oceans and convert it into a new yarn. We are also removing its plastic before it degrades into microplastic. The social part, as we are tapping into the local communities and helping them to raise their awareness and education. And the governance, the traceability with a full chain of custody from end to end, a certification number for each of our fabric, and a licensing system. It's a proper verticalized, in that case, horizontal process. So we control the collection point to see where the plastic is being collected into the water, which is our main mission. the expertise. Our two shareholders, Antex and Vika, are probably one of the few remaining spinners existing in Europe and Latin America that can spin this degraded plastic that we are recollecting into a quality yarn. And then the community of 2,500 brands and knitters that are using this yarn to create fabric and then final product. So it's a purely vertical integrated solution. Our vision is to clean the ocean together. And by cleaning the oceans, we can engage the industry and inspiring the final customers to raise the awareness. We are working towards controlling all the chain, so collection, sorting, flakes, transformation into sequel marine plastic, the polymer, the chips, and then the conversion into the yarn. The yarn that has a pretty good environmental impact, so minus 37% of CO2, 34% of water consumption, and 40% of energy. Mainly working in textile, so in fashion, sportswear, swimwear, in automotive for the car seats of some of the famous brands in Europe, home and contract furnishing, and finally merchandising. We tend, and we have the chance of having factories in pretty much all the continents, not to move the plastic over, which is the issue of our competitors. Here we tend to have the lowest carbon footprint possible. So in Europe, we collect from the coast of the Mediterranean Sea. In Mexico, for Latin America and US, we collect in Mexico itself, etc. Difference with ocean-bound plastic, which are the ones that are collecting the plastic in the land up to 50 kilometers from the coast. We are collecting it from the water. So we are collecting this degraded plastic before it degrades into microplastic. So that's the real difference in our mission. Some of our historic milestones and customers. The typical feel-good slides about our customers. Some of the marketing that came out from our customers. So that's very important. Is that we are a B2B ingredient brand, and we rely on the brands to create a proper non-greenwashing advertising. And the fact is that we also provide to the brands all the assets, the digital and physical assets, to really not only ease the sales cycle, but also to create awareness and to communicate on the issue with the least greenwashing possible. And we are improving our roadmap for 2024. So digital passport on the left side. So the idea to, as we are controlling the chain, to be able to give to the final brand and final customer this ESG KPI that we saw before. So as we will implement it in 2024, this digital supply chain we will be able to get this traceability end to end to the customers, an environmental impact and the social impact. We are also working on the right side on the foundation, so keep SQL initiative on the operational side to clean the ocean, and to have SQL foundation on the right side to regenerate the ocean, to plant Posidonia, Gorgonia, Lotus on the Nile to reoxygenate the water. This type of activities that are, let's say, complementary to the cleaning of the ocean. We are working on new materials, so collecting right now fishing nets in PA6 and PA66 to be able to convert them chemically into a new yarn, so that to cope with other markets, first layers, etc. We have also working on the chemical recycling. So we already did several tests, industrial tests in 2023 and 2024, where we collect more degraded plastic, more colors, and turn them into a new qualitative yarn. It also enables us to recollect end-of-life garments and textile, and to convert it back into a new yarn. So that's what I would call the infinite loop. And then we are working on the marketing development. So trying to use our community to step up in terms of collaboration, work with artists, athletes around the sea, around the ocean, and work with the brands to raise the awareness. We are working with events, concerts, etc., to also increase the awareness by explaining to the people on the ground what the ocean contamination of plastic means, how we can solve it, by improving as well the marketing assets. And we are also increasing the awareness by creating recollection points in Europe, where we will put together scientists, sports people, and artists, and to create unique days of recollection. And that's it. Thank you for your time. Thank you.
So thank you to all our speakers today for sharing their entries to the 2023 RECOUP Awards for the product related categories. Just want to quickly, before we log off, so we do have another webinar next week looking at some of the technology finalists for that technology award. So that is next Thursday, 9th of May, 10 till 11:30. And then the final thing to say is I hope you've been inspired today by some of the entries that got shortlisted last year. So just a reminder, the entry deadline is the 28th of June. So please do enter. You never know, you could be the award winner that we announce at the pre-conference networking dinner. If you have any questions and would like to follow up anything with us, then please contact us at inquiry@recoup.org. And just a reminder that the application forms are available on our website. So thank you very much for joining us today, and we hope to hear from you soon.